right, so today is all about inverse functions. You'll need your unit circle or your chart, so make sure you have that handy tool out. Here we go. To make a function, it must pass the vertical line test. Remember the vertical line test. So, you know how sine keeps going on forever and ever, right? If you were to take the inverse of it, it would go on forever and ever vertically. Well, that wouldn't make a function. So in order to make a function so we can solve for sine, we have to cut it. We have to narrow down the possibility so that is just part of that curve, not the entire curve. So when we're looking at this for sine, right, I'm only going to look between negative pi over 2 to pi over 2. All right? So if we were to graph this, we would be at negative pi over 2 to positive pi over 2. Yeah? And then 1 to negative 1. Ooh, graphing came back. I'm sorry, did I say you weren't going to graph anymore? It's so funny. Black, here we go. Negative 1, 0, and then 1 makes sine look like this. True? Yeah? Oh, it looks like, was that forte? No? I don't know. What is that? I don't know. Here we go. All right. The reason why I'm only looking at this little snippet of sine is because it passes the vertical line test, where if you take a vertical line, it'll only cut the function once, right? Here we go. The domain is all the what values? The x values. So the x's go from negative pi over 2 to pi over 2. Do you remember how to write domain and range from Algebra 2? Oh, yeah, no promises. All right, there you go. The range is all the y values, right? Lowest y value, maybe 1, and highest y value, 1. Okay, so to find the inverse, you switch the x and y values. So this time, the x's will be your negative 1, 0, and 1. Right. Negative pi over 2, 0, pi over 2. Right. So again, you just switch the x and y values. So here's negative 1 to positive 1, and your sine goes from, your y goes from pi over 2 to negative pi over 2. Okay. Yeah. All right. Now be careful. The curve basically will flip over. So here's what's happening. Yeah. All right. So we're at negative 1, negative pi over 2, 0, and then pi over 2, right? So instead of curving up this way, it's going to curve down this way. And instead of curving down like this, it's going to curve up like this. Yay? So that would be the inverse of the sine. It would just like switch around. Okay. Notice the inverse of sine. What's the domain at this time? Yeah. And then ranges pi over 2. Okay. The most important thing is right here. Right? If you're looking for the inverse of sine, that means your answer has to be between negative 1 and 1. We talked about this way back in the beginning. If you remember, sine and cosine is between negative 1 and 1. Secant and cosecant is outside negative 1 and 1. And tangent and cotangent was everything. Yeah, right? Like reach back into your mind. We talked about this, but this is why it is what it is, right? Same thing for sine. Here we go. For sine, the snippet that we look at goes from between 0 and pi. So you're going from 0, pi over 2 to pi, and again from 1 to negative 1. Yay? So it goes 0, 1, 0, negative 1, and cosine we know goes like this. Truth. False. What you gonna do? D. Nene. What's the domain? Hello? 0 to pi. And range? Yeah, usually you go from least to greatest, so -1 to 1. Yeah? So the inverse cosine, the x's will be? Yeah, well, it would be 1, 0, -1. I'm just switching literally what I see over there. Yeah. And then 0, pi over 2, and then pi. Yeah? So we're going from -1, 0, and 1, and then 0, pi over 2, then pi. Okay. This transformation's slightly harder to see. Okay, so you have to trust me on this one. Put a little faith in the flag. Here we go. 1, 0 is over here. 0, pi over 2, and then 1, -pi. All right, so if you can imagine, yay? So this part over here is going to flip down to the bottom. So it's going to look something like this and this. So there's like looks like an S shape. Oh, that's terrible. It's supposed to cross at -1. Sorry about that. Let me get rid of that. Hang on. Yeah. Delete. Okay, so it goes more like nope. Other way. Sorry, my bad. Delete. I know. I'm sorry. There it is. That's pretty. Oh, that's pretty. Yes. So in this case, what's the domain? Yeah, -1 to 1. And again, the range is just from 0 to pi. But the most important part is right there because that tells you what your answers can be. If you're looking at negative cosine, then your answer can only be between -1 and 1. Otherwise, not solvable. Sorry. Yay? Yay. All right. Here we go. Bye-bye. Tan. All right. Here we go. Tan is undefined at -pi over 2 to pi over 2. So just a recap on how to draw this, right? We got -pi over 4, -pi over 2, and then pi over 2, and still 1 to -1, right? We know it has an asymptote at -pi over 2. It's been so long since we graphed. Ouch. Graphing wasn't bad, was it? Okay. Remember that tan curves up like this. It's not a straight line, so it curves up, curves down. Yay? What's my domain? Good. To -pi over 2, right? Does it include or exclude pi over 2? Excludes, because the asymptote. So instead of a bracket, you're going to write a parentheses, right? Since it excludes it, the only difference with the domain is it becomes parentheses -pi over 2 to pi over 2 because it's excluding those endpoints. Okay? What's my range? Infinity to -infinity. Because it keeps going up and it keeps going down, right? Okay? So the range, and since infinity you can never get to, it's also parentheses. It goes from -infinity to +infinity, like so. Yeah? Okay? So the inverse of tan, which, by the way, that -1 we remember is inverse, right, from algebra 2? Okay. Here we go. Switching the x's, so the x will be undefined, and then -1, 0, 1, then undefined, and then -pi over 2, -pi over 4, 0, pi over 4, pi over 2. Basically, we're just taking this and then flipping it on its side. Yay. All right. So here we go. Yeah, all right. So we're at the x's. Did I switch it correctly? Yeah. Yeah, okay. Yeah. Here's negative 1, and then 0, and then 1, and then this is pi over 2, this is negative pi over 2. Okay? Yeah, the asymptotes are going to be sideways, like so. So, and then we've got negative 1, negative pi over 4, 1, like so. So something in the vicinity of that. Yeah. Okay? Good times. Bless you. Aw, bless me, Ultima. Here we go. No one? Nope. All right. What's the domain? And that's why I was telling you at the very beginning when we first met all that time ago that inverse tan could be anything. Right? You can find the inverse tan of 225 or negative 225. Right? The range is still negative pi over 2 to pi over 2. But in this case, we're just looking at the domains. Okay? So make sure somehow you highlight the domains of all of the inverses, because that's the important part. Did all that work for the domain? Sweet. Okay. You got your handy dandy unicircle? Handy dandy? Oh, okay. Oh, boy. All right. Here we go. You're also going to need the range, which is not bad, but you're going to need the range. Here we go. For all of these, arc sine is the same thing as inverse sine. These all mean the same thing. Yay? Okay. Since we're looking at arc sine, are you ready? Then our range has to be between, what's the range for inverse sine? What does it say? Look at the front. Look at the front. Yeah. Right? The range will be negative pi over 2 to positive pi over 2, which means you can find your answer in which quadrants? All right. Here we go. We know this is pi over 2, right? If you go this way, it's pi over 2. If you go the opposite way, this is negative pi over 2. So where are my answers in? Quadrant 1 and quadrant 4. Yay? Okay. So, here we go. If the arc sine in quadrant 1 or 4 is root 3 over 2, then what is y? Right? Take a look at your unit circle. Take a look at your unit circle. Where is the sine root 3 over 2? Or take a look at your back, right? Which is it? Oh, radians, sorry. Radians. Pi over 3, right? Or 5 pi over 3. Yay? This is quadrant 1. That's the answer in quadrant 2. So you have 2 possible answers where it could be. Does that make sense? Or no? It do make sense? Okay. All right. Now, yeah, since it is at negative, yeah, it's all good. Okay. For the most part, since sine is that between negative pi over 2 to pi over 2, you're going to see the answer just be right here for now until we start solving the equations where it could be in both. But for these ones, since sine has to be between negative pi over 2 and pi over 2, we're just going to go with the first answer for that one. Yay or nay? Yay. Okay. Yeah. What's up? Yeah. It would still have the same reference angle. So yeah. Yeah. Okay. Here we go. In quadrant 1 or quadrant 4, where is sine negative a half? Where is it? 11 pi over 6. It is. So here's the deal, right? In the negative 1/2, if this is 11 pi over 6, excuse me, then this angle right here has to be 12 pi over 6 minus 11 pi over 6, which is 1 pi over 6. But since you're going negative, it's going to be negative pi over 6, right? What? Okay, here's another thing. Here's another thing you do. Remember that because it's negative, you can pull it to the front. So it's y equals negative sine of a half, which is negative pi over 6. There it is. What's up? The test. Oh, you know what? I remember now. Sorry. Since this is positive, you're in quadrant 1. So that's why we can get rid of this one. Since this is negative, then we're in quadrant 4. There it is. Yeah, so, yeah. All right. So this next one, positive or negative? Where is it? Where's my answer at? 1. It's in quadrant 1. Yeah. Okay. So you're looking in quadrant 1. Where is the sign root 2? It does not exist. Because root 2 is bigger than 1, right? This last one does not exist because root 2 is bigger than 1. So it's outside of the domain. Negative 1 to 1. Exactly. So, again, just if you have a little chart, you do quadrant 1 if sine is positive, or you do quadrant 4 if sine is negative. That's why I couldn't give you both answers. Like, yeah? Okay. Here we go. Cosine. All right. For cosine inverse, right? The range is from look at the front. The range. Yeah. 0 to pi. Right? Yeah. Look in the front. No, the front page where we do the graphs. Yeah. Right? So the cosine, the range is from 0 to pi. Which means that, you ready? Here we go. To find cosine, you're going from 0 to pi, which means cosine can be found in quadrant 1 and 2. You find cosine in quadrant 1 if cosine is, yeah, greater than actually positive. Positive, right? 1's always positive. And then this one if cosine is negative, less than 2, right? What if it is 0? It is. So what's the arc cosine at 0? Where is cosine 0? Where? Pi over 2. Right? Yeah, cosine is 0 at pi over 2. So another way you can think of it, right, is the way you can rewrite this is the cosine of y is equal to 0, then y has to be pi over 2. Yes, for always gradients from now on, okay? Yeah, unless otherwise stated. Yeah? Alright, so that's a quadrilateral angle and will help you. But B, cosine is a half. So what quadrant should I be looking at? Quadrant 1. So you look in quadrant 1, and where is cosine a half? Pi over 3. Y is equal to pi over 3. Done. Yay? That's good stuff. That's good stuff. All right. Here we go. Oh, here, otherwise stated. Oh, any questions for a lot of tangent? Very good. All right. There we go. Did I go too fast? Good. Cut. Now go back. Go back. Did you draw the map? Okay, do that, because that's important. Yeah. Yeah? Okay. Here we go. Tangent. What's the range for tangent? Yeah, the range? Yeah. Yep. Okay. So tangent goes from negative pi over 2 to pi over 2. Is that right? Oh, not including. Not including, right? Okay. So for tangent, again, you have two cases, positive or negative. If you remember, Eddie, what's up? It's the same as sine. Yeah. So you will find your answers in quadrant 1 or quadrant 4. Right? It's in quadrant 1 if tan is positive, and quadrant 4 if tan is negative. Okay? Eddie, did you have a question? Or are you good? I did. Oh, here we go. The first one. What quadrant am I in? This is quadrant 1. So you look at your handy dandy cheat sheet. See there. Yeah. Pi over 3. Nice. So theta has to be pi over 3, or degrees. Degrees. Sorry, it's 60 degrees. You're right. You're right. I should not have. There you go. Hey. Yeah. Okay. Here we go. Cosecant. Oh, cosecant. That's sine, isn't it? Right? Yeah. So for cosecant, first of all, it's the same thing as sine, because the same thing as sine. Right. So it's just the inverse of sine, right? So if cosecant is negative, what quadrant am I in? You're in quadrant 4. Yeah. So you look in quadrant 4. Where would the cosecant be negative root 2? Where is it? Where is it? Yeah. Yeah, it is 315. You're right. Yep. Oops, sorry about that. This is 315 degrees, or remember that if it's 315 this way, then how much is it this way? Negative 45 degrees, like that. Yay? Okay. How are we feeling? Tad cold? Yes, my love. Because it has to be between pi over 2 and negative pi over 2, not pi over 2 and minus pi over 2. So it's negative. So it's the same thing as last time, just pull the negative out. Why did you do that? Langston. There we go. Apologize. What's that? Oh, 315. So cosecant is the flip of sine, right? So if this was the flip, then at 315, if you flip that, you would get negative pi. Negative root 2. Sorry. Okay? Yes. Get that. Because literally it's 1 over root 2. Which is why I like to leave it. Yeah, because that's good times. Alright, here we go. On your calculator. Let's take a minute. If you don't have a calculator already, go ahead and grab one. bury the survivors? Oh my god. You ready? Alright. Oh, so. Eddie, I calculator. Here we go. Alright. If it's not on the unit circle, then use a calculator. We'll practice both radians and degrees. Step 1. For this first one, make sure your calculator is in radians. Does everyone ever have to do that? Yeah? Okay. Here we go. To stick this in your calculator, remember that secant is 1 over cos. So this is 1 over the inverse cosine of -4. Go ahead and stick that into your calculator. Oh boy. Why is it a domain error? Look at the number. Look at the number. -4. Cosine has to be between what and what? Right. -1 and +1. But since this, yeah. Oh, it's all good. Here we go. But since this is bigger or less than -1, this is an error. Yeah. Domain error because it's not in the domain. Oh, wait a minute. Are we supposed to be 1 divided by? Try this. Oh, that's what we did. Sorry about that. If you type that in, that's error. But what you're supposed to do, sorry, is 1 over -4. There you go. There you go. Yeah, well. So 1 divided by -4. Yes. Okay. Now what do we get? In radians? I got 1.82. Are you in radians? Okay. Did you use second cosine? No. You put 1 divided by cosine. Yeah. So you should get 1.8235 if I were to round it.
I got -0.65.
Okay, let's see what you did. So first make sure it's in radians. Okay, do 1 divided by -4 equals second cosine.
Oh.
Yes. All right, we're good. Sweet. Okay, so if you type it in that way, the first way, you're going to get an error because cosine is between -1 and 1, but secant can be, right? All right. Arc cotangent of this one in degrees. So go back, make sure your calculator's in degrees. Right? All right. So if this is arc cotangent, then this will be the arc tangent of 1 divided by -0.2528. Is that right? 1 divided by -0.8. In degrees? What'd you get? Positive or negative? Yeah. Yeah. This should be -75.81 degrees. No. I think it's negative. Yeah. Because tangent is the same thing as sine, where it could be a quadrant 4. Blurdy blur. Yay? Okay, here we go. 2 opposites happen. What do they do to each other? Cancel, right? They fall in love and have beautiful children. Here we go. No. An inverse cancels the actual function. So if you have arc sine and a sine together, they cancel each other out. So like that next example, if you do the sine of the arc sine, they cancel out. This is just 1/2. That's it. So the arctan of tan of pi over 3 is just pi over 3. And the secant inverse of secant of pi is pi. So if it's the exact same thing, it cancels out. If not, a little bit more work. Little bit. Just a little. Okay. Here we go. Oh, whoa, 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 whoa. I go down. I go down. Yeah. Feliz Navidad. Lactose. Oh boy. Oh boy. Yeah. Okay. Here we go. All right. Well, what happens? What happens if it's two different things? It's okay. It's okay. Here we go. Sine is positive. Inverse sine is positive, so where am I looking? Quadrant 1. We agree. Okay. So we're looking at quadrant 1. Okay? In quadrant 1, where is sine 2/3? We don't know, do we? All right, here we go. So we're in quadrant 1. Sorry about that. Here we go. Sine is y over r. Here we go. Yes! All right, so 2 over 3. 9 minus 4 is 5. So this is the square root of 5, right? We're in quadrant 1. Yay? So the question is, what's the cosine? What's the cosine? Is root 5 over 3. That's how you do these. Back to the triangle problems. Okay? And now you're so excited! You're so excited! What's up? What does it say cos? Yeah. So the cosine at this angle is root 5 over 3. Okay? Remember, the inverse is the angle, so you just write the angle. All right. Let's try it again. Where is cotangent negative? 4. Yeah. So remember, it's either 1 and 2 or 1 and 4. This one is quadrant 4. So we draw our triangle. Notice like a lot less words than your previous example. Right? Cotangent is what over what? So 15 over 8. Which one's the negative? The 8. 225 minus 64. I'm sorry. No, 225 plus 64. Divided by square root. 17. 17. Hey, Pete. Oh, thanks. Alright, so cotangent and tangent are the same. Remember, for tangent, it's quadrant 1 or quadrant 4. And since it's negative, it's in quadrant 4. So that's why we picked quadrant 4. Right? So it's like lots of stuff you have to take into account, right? Alright. Yay. So finally, the secant at this angle is 17 over 15. Joy. Joshua. Okay, so short synopsis. You have to figure out what quadrant you're in to draw the triangle just based on that much information. That's it. Okay? So to figure it out, like, just you're gonna have to remember this, or actually draw it out. When you do sine, it's quadrant 1 or 4. Okay? Cosine is 1 and 2, depending which positive negative. And then tangent again is 1 and 4. Notice what quadrant don't we touch? The third. There's never any answers in the third quadrant. So it's either 1, 2, or 4. Depending on what's positive, negative, depending on what. Yeah. How did you know so smart? Okay. Questions before I do the last question? You're good. Just gonna let it soak in. Okay. Yeah, Josh. Yeah. Uh-huh. Yeah. Quadrant 3. Or 4? You mean? Okay, because it's cotangent. Cotangent is the same as tan. So tan is 1 or 4. Right? 1, everything is positive, so 4 has to be where it's negative. Okay? Okay. Oh! 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 2 triangles! 2 triangles! Okay! 2 triangles! Yay! Okay, here we go. Triangle number 1. You're doing what? Here we go. Triangle number 1. Tangent is positive, so you're looking in quadrant 1. So first thing, you're looking in quadrant 1. Tan is opposite over adjacent. 16 plus 9 is 25, so this has to be 5, right? And let's call this angle A. Yeah? This one is cosine. Cosine is positive in quadrant 1. It's a minus. It's a minus. You're going to see it. Okay, here we go. Are you ready? Why did you put A there? Okay, here we go. 12 over 13. So 12 over 13. Switches. 5. Very nice. Let's call this angle P. So what this says, my dears, is sine of A minus sine, cosine.
Sorry.
If you need to refer to it's on your paper, actually. Exactly! Sine, cosine, cosine, sine. Right, Jordan? You're so excited. Here we go. All right. All right. So this becomes sine A cos B minus cos A sine B. I know, it's so good. It all comes together like a circle, a unit circle to make that. I was just inspired by your story, it's all. Here we go. What's the sign of A? What is it? Vowel 5 cosine B. 12 over 13 minus 3 over 5 and 5 over 13. Oh boy. 48 over 65 minus 15 over 65 is 33 over 65. It all goes like so. I mean, you've done this before. You just have to. You're just doing it with less instruction. Okay, less instruction. Yeah, it's good. Asparagus? Aspera? Aspera? Oh, what's aspera? Ah! Alright. Bien, ¿cómo te mueves? Es chango mantequilla, chango pelota. Alright, here we go. It's a good time. Good time. Alright, beloveds. Oh. No. Here we go. Alright. Just look at this one. Here we go. Quadrant not 4. Oh, it is 4. Oh. You're right, it's 4. It's 4. Here we go. cosine in my mind, which is nuts, so don't believe me. Here we go. Thomas discovered that our cotangent is negative is a quadrant 4. So here we go. We're in quadrant 4. Right. Cotangent is what over what? Adjacent over opposite. So the adjacent has to be 5, and the opposite has to be 1, but it's negative. Cotangent's adjacent over opposite, right? Right? It's okay. Let me call this angle T for Thomas. Yeah? So, let's see. Oh, wow. Okay. 25. Oh, my. 25 plus 1. 26. So this has to be the square root of 26. Are you ready? So this thing says sine of 2t. It's a double angle. T is the angle. You want me to use theta instead? You know what? Theta means t in Thomas. So yeah, we'll use theta because that means t also. Yeah? Okay, we'll use theta. Look at your formula sheet. Sine of 2t is equal to 2 sine theta cosine theta. It's all coming back in a fun way. Yeah. No buenos? No sabemos? Okay, so basically, draw your triangle. You gotta figure out where a triangle is. Draw it out. And then from that angle, because the inverse is the angle, that triangle gives you the angle. So really, this formula just says sine of 2 at that angle. It's a double angle. There's only one formula. And you triangle. Here we go. Sine theta is. And cosine is 5 over root 26. Alright, here we go. 2 times negative 1 times 5 is negative over, which reduces down to and they all live happily ever after. Yeah. Alright. How do we feel? Yay? Do you see why I gave you this? Yay? In a plastic sheet? You're gonna need it. Alright. There aren't that many problems, but try as many as you can before you leave today. The end. Finito or Filippo?